Boolean arrays are produced when NumPy arrays, or pandas DataFrames or Series, are compared using one of the 6 comparison operators. Boolean arrays are used to summarize data, create interaction variables, and to select values from arrays, DataFrames, and Series. Boolean arrays contain one of 2 values, true or false. In practice, true is treated as 1 when mathematical operations are applied to Boolean arrays. Versions of the 3 logical operators are available for combining Boolean arrays. All operate element by element. AND is implemented using the ampersand character or the NumPy function logical AND, or uses the pipe character or the logical OR function. NOT uses the tilde or the logical NOT function. Start by opening Lesson 15's notebook. Run the first cell, which is populated with code. This cell loads the momentum data, which we will use in this lesson. The first task asks us to determine which returns in a portfolio are negative. We create a Boolean array by comparing the return series to 0. We can look at the first 20 values using head 20 and running the cell. We see the output is a mix of true and false values. We use the same code on portfolio 10 to see which returns are negative. The next problem asks us to determine when both are negative. This requires using the logical operator AND. Since these are vectors, we cannot use the keyword AND. Here, I use ampersand, which works on Boolean arrays. Booleans are cast to integers when used in mathematical operations. True is 1 and false is 0. This allows common methods to be applied to Boolean arrays. For example, sum counts the number of true values, mean computes the empirical frequency of true values in the array or data frame. Multiplying a number by a Boolean operates like an interaction effect, where the value is preserved when the Boolean is true and set to 0 when false. We can use sum to count the number of true values. Using ampersand, pipe, and tilde can be a bit risky since comparisons, such as less than, are low precedence. This means they are often evaluated after other operators, which can produce unexpected results or errors. Let us look at code written directly with the 2 less than comparisons and the ampersand. Running this cell produces an error. This occurs since ampersand is evaluated first, and then the less than comparisons are attempted. The solution is to liberally use parentheses so that comparison operators are always evaluated first. Running the cell with the parentheses resolves the error, and we can see the sum is the same. We could also have used the function logical AND. First, we need to import NumPy. The function takes 2 inputs, the Boolean arrays. The value returned is the same. The function is safer than the ampersand, since any comparisons in the inputs are evaluated before the function is run. Despite this advantage, I find code written with ampersand, pipe, and tilde to be clearer than using the functions logical AND, logical OR, and logical NOT. Running the cell, we see the sum is the same. The second part asks us to determine when each has an outlier return, defined as being larger than 2 times the standard deviation. We need to compare the absolute value of the return to the standard deviation and retain those which are larger. Using the two large return indicator vectors, we can join them with ampersand. I forgot to transform the returns to absolute values. Here, I use the ABS method to compute the absolute returns. We can print the sum to show the number of occurrences of simultaneous large outliers. The next problem looks at the OR operator, a pipe. We can use the indicators previously created and use a pipe to perform the logical OR operation. Running the cell shows that it is common to have at least one negative return. We can alternatively use the function np.logicalOR to accomplish the same goal. Next, we look at the empirical frequency of negative returns. We construct the Boolean array by comparing momentum to 0 using the less than operator. Let us look at the head. We then compute the mean of this Boolean data frame to construct the empirical frequency. The final problem asks us to determine if any portfolios meet a specific condition. Any and all are Boolean reductions that convert a Boolean vector to a scalar. Any returns true if at least one element in the vector is true. All returns true when all elements in the array are true. Data frames expose methods that implement any and all. These operate column by column. The NumPy functions any and all default to operating over the entire array or data frame, and so default to returning a single scalar irrespective of the number of dimensions of the input. To use the NumPy functions column by column, pass the axis equals 0 argument. Using axis equals 1 makes any and all operate row by row in a data frame or in a two-dimensional NumPy array. First, we can look at the head of the data frame. These values are single digits, which indicate that the returns are in percentages. We can then test when momentum is less than -5. To determine if there are any true values, we'll use the any function, which operates column by column on the data frame. We can take a look at np any without any keyword arguments. Running this cell, we get a single Boolean value. np any defaults to operating over the entire array. We need to add the axis equals 0 keyword argument to get NumPy any to operate column by column. Any can be constructed by negating an all test. First, we determine when all returns are larger than -5%. We then construct an any using not of the all, where tilde negates the Boolean array. Boolean arrays are created when NumPy arrays, or pandas data frames and series, are compared using one of the 6 comparison operators. Boolean arrays contain one of two values, true or false. When used in mathematical operations, true is treated as 1 and false is treated as 0. Boolean arrays are combined using one of 3 operators: ampersand for and, pipe for or, and tilde for not, or one of 3 functions provided by NumPy. You cannot use the Python keywords and, or, and not on Boolean arrays. Attempting to do so will produce an error.